Yeah, this is about finding the rate of change of height of the tank contents, or is how fast this height is changing with time. That is, we need to get dH by dt of the tank contents. Okay, let us read the problem. This were again asked in this 2023 for a 2-mark question. A cylindrical tank with a diameter of 500 mm contains water with 1 gram per cc density up to a height h. Okay, we have a height of h, a 5 mm diameter round nozzle, no? 5 mm diameter round nozzle whose center is 1 centimeter above the base of the tank, has its exit open to the atmosphere as shown in the schematic below. The pressure above the water level in the tank has its exit. Of course, this is open atmosphere. The pressure above the water level in the tank is maintained as 2 bar absolute. And neglect all frictional and entry exit losses. Okay, the entry exit losses means, okay, this loss, no, we are simply taking the Bernoulli equation as such without any loss term. Using the acceleration due to gravity as the 10 meter per second square and atmospheric pressure as 1 bar, we need to find the change of height with respect to time dH by dt when h equal to 51 centimeter. So always, of course, dH by dt is a function of time, a function of height, because as and when the height is reducing, the rate of fall will be actually reducing. Initially, you have higher velocity because of higher head available. With h decrease, the velocity will actually reduce, which will affect the change of height with time. So we need to find this dH by dt when h equal to 51 centimeter. H equal to 51 centimeter. No, from the base, it is 51 centimeter. If we can also subtract this one because only this is the effective potential head available. Okay, this and all we'll see in the calculation part. So what is needed is we need to find the dH by dt of the tank contents. So okay, simply Bernoulli equation P1 by rho GV square V1 square by 2G plus Z1 equal to terms are 2. So P1 is 2 bar absolute. P2 is 2 bar. Sorry, this is one. P1 is 2 bar absolute. P2 is 1 bar absolute. That is given. And Z2. No, this is having a height of 1 centimeter. This is available at a height of h centimeter. So always what is needed is we need to find corresponding to h of 51 centimeter. So h you can take it as 51 centimeter. Z you can take it as Z1 you can Z1 is 51 centimeter. This is 51 centimeter, and Z2 is 1 centimeter. Corresponding to that only we are going to find dH by dt. Okay, so substituting everything. So this is Bernoulli equation. And we know this mass balance. Mass balance, of course, there is no mass in. So there is a mass out, and there is a change of height. Always mass in minus mass out equal to change of mass in the tank, which is mass in the tank is again volume into density of the tank. Density of the tank contents. Volume is again area into h. Again, area of the tank is remaining constant all along the height. So which is simply coming as dH by dt. Always area of the tank is nothing but the area over the point 1. The area of the point 1 is, of course, point 1 is keep on falling. Okay. So we have this mass flow rate, which is volumetric flow rate into density. So volumetric flow rate is A2, which is the area of the opening, and V2 here, velocity. So what is needed is dH by dt. So we can rearrange these rho getting cancelled. So V2 into A2 by A1 equal to dH by dt. So if you can substitute these values, we are done with. So what is V2? We have to find. V2, of course, we have to solve this equation to get the value of V2. Here, these are all known. These are all known. Only thing is, there is V2 and as well as V1 as well. Of course, V1, nothing but the velocity at the point 1. So this is point 1, this is point 2. Of course, the point 1 is keep on coming down. So point 1, velocity 1 can be written in terms of velocity at 2, simply from the, what is it, continuity equation, this volumetric flow, equality of volumetric flow. So from which we have this V1 written in terms of V2. V1 and V2 are related by this. Of course, V1 and V2 are having this V1 is 10 power 4 minus 4 into V2. But what is needed is here V2 alone. So you have to use this V1 in this equation. Of course, what is even we can ignore this V1 term completely, but still to check whether it is ignorable, I'm relating this V1 in terms of V2. So V1 is coming to be a very low value, 10 power minus 4 of V2. But again, if you substitute this, actually we are needing V1 square. So V1 square will be much, much lower in comparing to V2 square. This will be simply negligible. V1 square is simply negligible. And P1, P2, everything is available. Z1, Z2 is available, which is 51 centimeter and 1 centimeter is 0.5 meter. This is P1 minus P2 is 1 into, or is 1 bar, 1 into 10 power 5. Rho is 1000 and G is 10. So from which we get the velocity as velocity through the opening is 14.49 meter per second. And what is this? dH by dt. Already we have this expression. V2 you can substitute, you'll be getting dH by dt as this one. This is actually in meter per second. Meter per second multiplied by 10 power minus 4. So we will be having, this is at last coming in millimeter per second. So this is a fall of height with time. There is change of height with time. There is dH by dt is minus 1.5 mm per second. We need to report the absolute value of that. So the answer is 1.45. Of course, nothing great. We need to write the Bernoulli equation and the mass balance equation. So the mass balance equation is having in terms of velocity. The velocity has to be obtained from Bernoulli. Here there are two velocity terms. Of course, with reference to this opening, the velocity in the tank, or velocity of fluid at point 1 is negligible, or is 0. You can take it as 0. But even if the velocity is not negligible, what we need is velocity square. Velocity itself is 10 power minus 4 times the velocity of the opening, and velocity square will be 10 power minus 4 square. Minus 4 into minus 4. So we'll be having still low values of V2 square. So V1 square. So this is simply negligible. That's why we get the value of V2, and substituting that in the mass balance equation, we get as 1.45 millimeter per second. So the answer is 1.45 millimeter per second. Okay.